In this video we're going to talk about brackets and how to work with them in algebra. So we might want to remove the brackets or expand the expression. For example, what will we do if we had this expression 5 brackets a plus b? What happens if we remove the brackets or expand this expression? Well, you have to multiply the 5 into the brackets, it's called. So first, let's just give ourselves a bit more room. Let's write that expression again. 5 brackets a plus b. We do like this. First, we multiply with the a to get 5a, and then we multiply this 5 with the b. This is called the inside term, this is called the outside term sometimes. So we've got this 5 multiplied by this a gives me 5a, and this 5 multiplied by the b gives me 5b. So this is just another way of writing it. This 5a plus 5b is equivalent to 5 brackets a plus b. And you might also hear this being called the distributive law. Or rule. So that's basically it. What you have to remember though is you have to include the signs of these coefficients or the signs of the variables. So for example, I might have, let's do different combinations. Let's have minus 5a plus b. Well, that would be, you have to take into account the minus, so minus 5 times a is minus 5a, and then minus 5 times b is minus 5b, because this is a little plus here. So minus times a plus is a negative, and a minus times a plus is negative. So we've got negative 5a, negative 5b. If we were to have minus 5a minus a plus b, that would give me minus 5 from here multiplied by another minus a here. Don't forget the negative sign there. And then minus 5 times by positive b there, which gives me minus 5b. But we've got to do something about this. Look. So that becomes minus times a minus is a plus. 5a minus 5b. We finished up with that one there. How about if we had minus 5 in brackets minus a minus b? Well, we'd have minus 5 in brackets times minus a from the first one, and then minus 5 or plus negative 5 times negative b from the second one. So we know already that minus 5a times minus a is positive 5a, and then we've got another minus times a minus. Let's rub that out, that should have been a b there. Minus 5 times minus b is plus 5b, so we've ended up with two positive expressions. What about if we had positive number in the front and the negative numbers inside? Well, it would be 5 times minus a plus the second lot of terms, which would be 5 times minus b, which would be 5 times minus a, pull the minus sign out the front because this is a positive 5. So we get negative 5a there, and then negative 5b there. What happens if we multiply a plus b in brackets with c plus d? Well, we have to follow a certain procedure. What we do is we multiply the inside 2, a times c. Then we have to multiply I'm going to try and use color coding here, so we're going to multiply the inside with the inside of the first one with the outside one of the second one. That gives me a multiplied by d. Then I'm going to multiply the outside term of the first bracket with the inside term on the second one. That gives me b times c. And finally, I'm going to multiply the outside 2 plus b d. So all of this over here is is equivalent to this over here. We've expanded, we've removed the brackets, we've multiplied these two binomials together to give us the sum of terms on the right hand side. Now, some interesting things happen if we have identical binomials. These are called the quadratic rules. So we've got here two brackets, a plus b in brackets, all multiplied by a plus b again in brackets. So if we follow the rule that we had up here, then we end up with these two first, a times a, which is a squared, plus a times b, which we just write ab, plus another lot of ab, because b times a is the same as a times b, plus b squared. And if we simplify these two here, this is just 1ab, and this is another lot of ab. This gives me 2ab, so I get a squared plus 2ab plus b squared. Now, another quite smart way of looking at this product is by drawing it up as a square or rectangle. So here is my square of length. Let's draw some lines in here. This length here, from here to here, is length A, and this is also A. This bit here is a square of length A. This one here has, this bit from here to here has length B, and also this bit here is length B. So the whole thing has length A plus B. Well, just from the rules of geometry, we know that this square has area A squared, and this area here is worth b squared. So we've already got an a squared plus a b squared, which is there's my a squared and there's my b squared. And this area here is an a times a b, so this is ab. And this area here is also, this length is a from here to here, multiplied this by this length here, which is ab. So the total sum of this area is a squared plus b squared plus two lots of ab. This is the same thing as this, but just in a picture form, if you like. It's easier to visualize. And this thing here, a plus b in brackets, we could also simplify. You often see it simplified as a plus b all squared. And that's equivalent to a squared plus 2ab plus b squared. And don't worry, you don't have to remember this. This is normally in the formula booklets that you're given with the exams. Likewise, and I won't prove it here, but you can prove it for yourself in a task. There are two other rules which you'll need to be able to apply, and that is a minus b squared, a minus b in brackets all squared, is equal to a squared minus 2ab this time, and then plus b squared. And then there's something called the conjugate rule, which is when you have a plus b multiplied by its conjugate, and its conjugate is when you change the sign of the second term. So this is a minus b. That ends up with just as being a squared minus b squared, quite simply. And that is called the conjugate rule.